Hello, welcome to Lesson 17, Quantitative Evaluation. By the end of this lecture, you will be able to describe the steps involved in a quantitative user study, list 2 criteria for a good hypothesis and use them to critique a hypothesis, suggest inclusion and exclusion criteria for participants for a study, and recommend metrics for usability and user experience. Last time, we discussed qualitative methods, such as direct observation methods like silent observation. In this case, the participant performs the work or task, and the evaluator silently observes, like so. Today, we're going to talk about experimental structure, which can work for both quantitative and qualitative methods, but is especially appropriate for quantitative methods. Let's say you want to compare keyboards on a mobile phone. You might have 2 different phones with physical keyboards, the BlackBerry Key 1 and the Samsung Stratosphere, and 2 with soft keyboards, a swipe technique on an iPhone and the iOS keyboard that is typically the default on an iOS device. How would you structure an experiment? Well, you might follow an experimental structure like this. You might create a hypothesis, decide on your participants, create a method that has an apparatus, a task or procedure, and measures, and then doing data analysis. What is a hypothesis? Well, it's a prediction of what might happen. So I want you right now to pause and write down as many hypotheses as you can for our experiment in 1 minute, then continue. In this case, we're going to have the video play through and you're only going to upload 1 deliverable for this lecture to try and make it easier for the people watching at home. So go ahead, pause, write down as many hypotheses as you can for our experiment in 1 minute, and then we'll continue. Go for it. Some examples of the hypotheses that you may have come up with are physical keyboards have a higher average word per minute WPM score than software keyboards. Swipe will have a lower average word error rate than iOS keyboard, or participants will rate the Stratosphere keyboard higher on UX questionnaires than the Key 1. Each of these has a very specific expectation of what might happen. They may or may not be true, but they do give you an idea of what you're trying to evaluate, and they can be rephrased as questions. They also have specific metrics, which we'll talk more about later. A good hypothesis is one that can be falsifiable. Can a logically opposite statement be made about it? For example, can we disprove that hypothesis? And testable. Can an experiment be designed to test the statement? Can it be completed within a reasonable time frame with the resources available? So I want you to take 1 minute to label your hypotheses as falsifiable, testable, and feasible. Then continue. Again, just pause the video and then you'll upload your entire worksheet at the end. Go. Here's the experiment. How do you determine who can participate in your study? You might come up with inclusion or exclusion criteria that determine whether someone is able to take part, and then you might sample from people who are eligible using sampling methods. So if we have this set up, we might consider some different criteria. Inclusion criteria are who you include in the study. So people between 18 and 65. You might want intermediate French learners if you're doing something with a language app. You might ask for undergraduate university students because they have that experience or they are the target population for the system that you're developing. Or people with a smartphone. Exclusion criteria would be who you don't include in the study. So regular users of your app might bias the results if we're looking at learnability. Or people unfamiliar with or unable to accomplish smartphone typing might be inappropriate for a study. You want to think very carefully about the inclusion and exclusion criteria for your study because you want to have as diverse a population as possible, both for external results and to allow people to be included in your research process, since we typically view participants as people that we are working with, not people that you recruit as subjects. We really are working with them to try and get feedback to improve the system and design something that meets their needs. But there might be reasons that they cannot accomplish the task or lead to the insights that you need for your study. In that case, you might include them in the exclusion criteria. Sampling is an important way to figure out who you might reach with your study. You can't ask everyone in the population, so you typically collect a sample. You then make inferences about the population from that sample. Some methods might include simple random sampling, which is typically viewed as the gold standard. From a population, you select a random set, and then they take part in your study. This might be difficult to do, so some people use a convenience sample. You stand in the corner and ask anyone who comes by. This is often biased and typically not what you want. But if you can do this in certain areas, or you're actually trying to recruit a certain targeted population, you might be able to physically recruit them in certain areas. That's a little bit different than a convenience sample, though that would be purposive sampling, just sampling with a purpose. Stratified sampling is dividing the population up into groups. These are strata, and sampling from each of them to ensure that you get people from different regions, different ages. And this is a very good idea if you think that these different considerations won't be reachable from a simple random sample, and that you really want to consider each of these groups. When you do this, it's very valuable in user-centered design because that way you can ensure you have a strong variance in the different types of population groups that you want to study. And so a simple stratified sampling method is often very useful. So now please pause and write down who would you recruit for this study. Suggest inclusion and exclusion criteria and a sampling method. Take 2 minutes and then resume the video. Go. You might include adults aged 18 to 65 with no motor impairments and corrected to normal vision who own a smartphone. This might give you a strong base of people that could do the task in a way that doesn't affect different variables that you might be worried about or not worried about. And you may exclude people who own any of the specific interfaces under examination because you might be looking at learnability. Bear in mind that if you are not including people with motor impairments, then your results might not apply to people with motor impairments. And so you may not want to have this restriction, or you may want to specifically do another study that tries to include this population and supports them. It really depends on your study needs. And the goal that you should have with your studies is to try and include as broad and diverse a population as possible so that your designs support as many people as possible within the scope of your project. Experiments. What does your study look like? Here's where you get into the methods of your study. So when we have this, what would you actually do? You need to think about what kind of equipment you need and whether it's valid for the type of experiment you're doing. So in this case, you might need these different smartphones, and you might need to know whether they are bug-free. Are they going to have alerts interrupting in the middle of your experiment? So you have to set them up properly to make sure that they can handle the experiment the way you want them to. When you report on your study, you need to provide a detailed explanation of all the equipment used in the study, known as the apparatus. It should be possible for someone else to replicate your study. This is the gold standard in reporting your methods. You write it in a way that anyone else could read your report and conduct that study as well. Your choices can affect the generalizability of your findings. Will your findings only make sense in your specific setup, or is it generic? And here's where you need to think about external validity or whether it is replicable. Again, why you want it to be replicable so that people can replicate your study. So then you start to think about the task or procedure that people do once you have your apparatus. What does your study look like? What will the people do during the study, and how will you ensure consistency? Often with a quantitative experiment, you're trying to control many variables. The room that they're in, the actual physical phone that they're holding, the latency in that particular phone, etc. So you want to make sure that's very consistent between people, and that means that you also want to have the same instructions for every person. So with this experiment, you want to make sure they're going through the same task, or a similar task, might be a little bit randomized what they're actually typing, but you need to make sure that they're going through the same thing. The task in a quantitative evaluation is not the same as the task in task-centered design. It's more like a use case because it understands what solution or system that you're working with. It is a step-by-step procedure that each participant follows. To reduce noise in the data, a sequence of steps should be consistent between participants. So I highly, highly recommend having a study script for experimenters to ensure that the participants receive the same instructions. Often in these types of studies, you might automate a lot of the study by having an application that walks people through the evaluation and presents the different interfaces in the right order. You might still pair this with a script so that you know how to welcome the participant if you're doing an in-person study, or break the ice, etc. in a virtual study, and to direct them through. So coming up with a script is always an essential part of your experiment plan. Now it's your turn. When I say go, pause the video and write down tasks that you would suggest for a study. After 2 minutes, continue with the video. So here's the study. Go. So some examples for a study might be typing an email, typing a script provided by an experimenter, or the experimenter dictates and the participant types. Each of these has some trade-offs, and so it depends on whether you want something more naturalistic, like writing an email, or more controlled, writing a script, in which case the text is the same across different interfaces. The experimenter dictating adds another level of complexity. How well is that participant understanding and listening to what you're saying, and adds a bit more cognitive overhead. So depending on what your interface is trying to achieve and where it might be used, you might use one or more of these tasks. When describing these tasks, you want to get into much more detail than just typing an email. You might say, writing a letter to your boss to say that you are unable to work tomorrow because you're sick, or something like that. So diving into the specifics of these tasks, making sure that the participant understands what to do is really, really critical. The next step is to come up with measures. What will you measure and what numbers are at play with our study? Measures are also called dependent variables or outcome variables. The independent variable or predictor variable in HCI studies is usually the interface or design. So usually you already know that you're comparing interface A with interface B, or you're comparing physical keyboards with software keyboards, etc. It should be possible to relate these different measures to the original hypothesis. So remember, in those hypotheses, I said word error rate, I said words per minute, I said rated higher or lower on different user experience questionnaires. So you want to be able to link back those questions to the hypotheses, which may or may not specify the specific measure. You might say it has a more positive user experience, but then in your measures, you say what that means is we're using a particular questionnaire and we're looking at these 3 different constructs. You can have multiple measures. This gives you more data available to analyze, but then it complicates the story. So the clearest studies, the ones that are relatively simple, show multiple metrics, and ideally you are able to disentangle that and come up with a clear story from the data. So again, it's your turn. When I say go, pause the video and write down the measures you might use in our experiment. After 2 minutes, resume. Go. Some of the examples in our study might include task completion time, words per minute, number of misspelled words, number of backspaces, and the number of pauses or posture changes. And you might need to combine these. You might look at error and task time because those are often inversely related. People might take more time to create fewer errors. So you also, in your task, want to say as quickly as possible or with as few errors as possible, or the combination, as quickly with as few errors as possible. Finally, how do you analyze the data? Well, some common analyses are ones that you might be familiar with from your stats courses. T-tests, ANOVA, regression, or confidence intervals are typically used to compare different quantitative measures. Plots and graphs are essential for exploration, communication, context, typically not for testing hypotheses, although if you have confidence intervals, you can clearly see whether things overlap or don't overlap. So there is often a correspondence to the associated statistical test from the plots. So the key takeaways from this lesson are that a quantitative experiment has a certain structure. Drawing from the scientific method, you need to identify questions, hypotheses, identify your participants, create a method to execute the experiment, and do analysis of the results. Each of these steps is important for doing an experiment to evaluate an interactive system, so make sure you're able to plan a quantitative experiment. That's all for now. Thank you so much.